Hello class, we was is a review packet, review test 1, calculus 3. So we was doing, we finished problem number 14. Let's do problem number 15. Problem number 15. So problem number 15, grab your review packet and check it out. It say found the no vector equation. So if you have to do the 8, you have a P and you have a P naught 1, 0, and 1, and you have a Q vector, Q point negative 2, 1, 3, and you have R, you have 4, 2, and 5. Just let me check to make sure it's correct. 4, 2, 5, yes. So now the question is found the non-zero vector orthogonal to the plane. Okay, the non-zero vector orthogonal to the point PQR. So the vector orthogonal, you have to say let n vector be the vector, be the non-vector if you want, be the vector orthogonal. Okay, to the plane, passing by the point PQR. So now to find the vector n is just the dot product of PQ vector cross product of PR vector. So if you look at here, you have PQ, maybe you can have here Q here, R and P. So if you look at PQ vector, you have that vector and that vector. So if you take the cross product, it will go up. That's the n vector in 3-dimensional, okay? That's the n vector. So they ask you to find the normal vector. That's the normal vector. It's a vector orthogonal to the point PQR, okay? So you have that vector now, and now you can just take the cross product. Before you do that, so you have to find first, you have to find the PQ vector. And PQ vector is just negative 2 minus 1, and you have 1 minus 0, and you have 3 minus 1, and will lead you to negative 3, 1, and 2 vector. So the next one you have a PR vector. PR vector is just 4 minus 1, and you have 2 minus 0, and you have 5 minus 1. So this one is PR vector. You have 3, 2, and 4. So now you take the cross product of that one. You have here I, J, and K vector. So you have negative 3, 1, and 2, 3, 2, and 4. So if you take the cross product, so you will have for I vector, you will have parentheses 4 minus 4. And the next one you have negative J vector. You will have negative 3 times 4, which is 12, negative 12, and minus 6. Okay? So the next one you have K vector, parentheses negative 6, and minus 3. Let me check to make sure you have negative 6 and minus 3. Yep. And now the normal vector is equal to, here is 0. And the next one you have negative and negative, it will become positive. It will become 18. And the next one is negative 9. So here is a normal vector now. So now you have your normal vector. Now the next question is to find the area. So the way you have to find the area now is the area of what? The area of the triangular. Okay. The area of the triangular PQR is equal to 1/2 of the normal Q vector cross product of PR vector is the same if you write down 1/2 of the normal vector of the norm of the normal vector. Okay, so then for the area of the rectangular PQR, it's just because we are working in 3-dimensional now. If you take, if you have to do the area in 3-dimensional, it's different to the XY or ZY or KY plane. It's very different. Here is 3-dimensional, and to find the area of the triangular in 3-dimensional, that's the way you have to do it. You have to take the cross product first, and then take the 1/2 of the cross of the norm of the cross product. Okay, so you have this one. You have 1/2 of the norm of the normal vector. So let's find first the magnitude of the normal vector. Is equal to the square root of 0 square plus 18 square plus -9 square. It's hard to find the number, okay? But you just have to figure out it. So this one is just a square root of 18 square plus 9 square. So you have this one. So now the area of PQR, it will become 1/2 to the square root of 18 square plus 4 plus 9 square. And that's it. That's the question they ask you. And that's also the first question they ask you. This is the second question they ask you. Okay? Now let's do the next one. Just take a look at it and keep copy. And you can stop if you want. You can stop. You can pause it and until everybody finish the copy. And let's move on. So let's do now question number. I can do more if you want, but it's the same process. It's the same process. If you want me to do the B, I can do it. Okay, since nobody can't hear me, I'm the only one who talk. Just let me do the P then. No, the B. B you have 0, 0, and -3, and Q is the coordinate of 4, 2, and 0. And you have R. R you have 3, 3, and 1. Okay, you have those points. So same thing, they ask you to find the non-zero vector orthogonal. So the non-zero vector orthogonal is N is equal to the cross product of PQ vector of PR vector. That's the way you have to do it. Okay? So now let's find the PQ vector is equal to 4 minus 0, and you have 2 minus 0, and you have 0 minus parenthesis -3. So then PQ vector is equal to 4, 2, and you have 3. Now let's find the PR vector. PR vector is equal to 3 minus 0, and you have 3 minus 0, and you have 1 minus parenthesis -3. So PR vector is equal to 3, 3, and you have 1 plus, this one is just a 1 plus 3, which is 4. Okay, now let's let's find the normal vector. So the normal vector is equal to the cross product of this one. P is a cross product of 4, 2, and 3. And you take the cross product of this one. 3, 3, and 4. And this one is just, you have I, J, K vector. So you have 4, 2, and 3. And 3, 3, 3. Okay, you have this one. So you have I, if you take I here, you have 6 minus 9, negative J, and you have 4 is 12 minus 9. And then last one you have plus K vector, and you have 12 minus 6. So the normal vector n is equal to negative 3i, and you have 9, 10 is 3. So you have negative 3j vector. And this one you have 4 is 5 is 6 is plus 6k vector. So that's the normal vector. Okay, that's the question they ask you for I. Okay, that's the question first. They ask you for the I vector. I. So now let's do the second one, which is to find the area of the rectangle for the B. So the area of the rectangular PQR is equal to the same thing, 1/2 and the norm of the normal vector. Okay, so you have the area of the square root of this one, negative 3 square plus negative 3 square plus 6 square. Okay, and you will have 1/2 square root of 9 plus 9 plus 36. And this one is just 1/2 square root of 18 plus 36. 36, 18, and you have 4, 1, and 5. 54. 1/2 square root of 54. That's the area. So now, I think that's it. That's all. So the area of PQR is just square root of 54 divided by 2. Okay? That's it. That's the question they ask you. So, and now let's move on to this number 16. Now, number 16. You can take a look at it and go slow. Okay? Now, let's do number 16. Number 16, you have found the volume of the parallelepiped with the adjacent x, PQ. Okay, you have 8. So you have 8, which is P is negative 2, 1, and 0. And you have Q is 2, 3, and 2. And you have R, which is 1, 4, and negative 1. So S is 3, 6, and 1. So now the volume of the parallelepiped, let's call it V, be the volume of the parallelepiped, is equal to, now is the norm, be careful here, is the norm of PQ vector cross product of PR vector. I mean, it's just the norm. The norm times the vector. Okay? And then you take the dot product of PS vector. You take the cross product here and you take the dot product here. So, and you take the norm. So you have this one. Okay. Now, first we have to find the PQ first. The PQ vector is 2 minus parenthesis negative 2, 3 minus 1, 2 minus 0, vector, and which is 4, and you have 2, and you have 2. The next one is PR vector. So the PR vector is 1 minus parenthesis negative 2, and the next one you have 4 minus 1, and negative 1 minus 0, vector. Just let me check to make sure it's correct. Yes. Yes. Okay, good. So here I will have 3, and here you have 3, and here you have negative 1. So now let's find the PS vector also. So the PS vector, the S is 3 minus the P minus parenthesis negative 2, and 6 minus 1, and 1 minus 0. So you will have 5 and 4, No, and 5. 5 is 6, take away 1 is 5, and 1. Okay, you have this one. So now, let's find this one first. Look at here. Let's find this one first. Let's find this one first, and after you can take the dot product, okay? Found this one first and take the dot product. So the PQ vector first. PQ vector cross product of PR vector is equal to I, J, and K vector. So if you look at here, you have a PQ vector which is 4, 2, and 2, and PR vector which is 3, 3, and negative 1. So here you will have negative 2 minus 6. Okay, that's the I vector. Negative J parenthesis. So here you will have a negative 4 and minus 6. And the next one you have K vector. K vector which is 12 minus 6. Good. So PQ, cross product PQ and PR is equal to 8, negative 8. And this one is just positive, so you have 10. And here you have 6. That's it. So now you have to take the cross product to have this one. So you have a PQ vector. PQ cross product of PR vector. And you take the dot product of PS vector. Here. Okay? And this one is equal to negative 8, 10, and 6. And you have the dot product of PS, and PS is 5, 5, and 1. And you will have a negative 40, because 5 times 8 is 40, and you have positive 50, which is 5 times 10 is 50, and plus 6 times 1, which is 6. So you will have a 10 here, you will have a 10 here, you will have 10 here, 10 and 6, which is 16. So you will end up having 16. So that means the volume, since it's positive, you don't have to take the, you don't have to do the norm. You don't have to do the norm. Come on, have a seat. You're fine. No, it's fine. You can come. You can come have a seat. That's fine. I'm just lecturing. Okay.
Check on you. Yeah. We just wanted to say hi.
Okay, I'm fine.
Why are you here so late? It's 5:30 almost.
Yeah, I'm doing the lecture for you.
Oh. Okay, thank you.
Thank you for coming and say hi to me. I appreciate it, okay? Very good, very good, very good, very good. Thanks, guys. Okay, you have this one. So you have the V is equal to, so the norm, since it's positive, is fine. So the volume is just 16. That's it. Okay, that's the volume. Good. That's the volume. And it's the same process, same for the B is the same process as A. Same process, okay? Now let's do problem 17. Problem number 17. So problem 17, you have if. You say if 8 cross dot product of this one is equal to square root of 3, and you have 8 vector cross product of this one is equal to 1, 2, and 3. So they ask you to find the angle between A and B. That's it. So here, be careful here. Be very careful. So one thing you have to know is the dot product of this one will be the norm of 8 vector, and the norm of B vector is equal to the cosine of theta. And we know also 8 cross product of 8b. Cross product of 8b is equal to the norm of 8 vector, norm of b vector, times sine of theta. Okay. So the question, they ask us to find the angle between them. So if you divide them both sides, so what you get, that's our goal. So let's divide them. So you have a cross product of 8. Okay, here, let me write down here. Okay, that's fine. So you can take the norm of 8 vector, norm of b vector, sine of theta, and this one is just, okay, I will tell you later. And divided by this one, the norm of 8 vector, the norm of b vector. If you divide them both sides, so you will have this one is equal to the top, the one on the top. Look at here. If you look at the one on the top is equal to this one, 8 cross b. Here, 8 cross b vector. Here is a vector. And divided by 8 dot product of b vector. And this one is just, I think it's given, but I didn't write it down here. I think is, yes, here is a vector. Is a 1, 2, and 2. And divided by square root of 3. And that's what you get. And that's it. And then you can take the norm, and then you can have it easily. Okay, let's move on. Okay, you have this one. So now, okay, oh, sorry, I forgot something. Here has to be the norm, okay? That's the norm. Now this one is the norm of 8 cross b vector divided by the dot product of 8 and b vector. And remember one thing, okay? So when you come here, you have to remember one thing. You know this one is given 8 cross b vector is equal to 1, 2, 2 vector. Okay, you have this one. So now the norm of 8 cross b vector is equal to the square root of 1 plus 2 square plus 2 square. And which is what? 1 plus 4 plus 4, which is square root of 9. Because it's 8 and 9. This is 3. Okay? So this one you have 3. And remember 8 cross 8 dot product of b is equal to square root of 3. So now you can just say here, you can just say this one. Now you can conclude. And this one will cancel out, by the way. If you look at here, this one will cancel out. This one will cancel out. So what you end up having is sine theta divided by cosine theta. Here. Okay? On here, this one comes from here. Okay? And it's equal to this one, the one on the top is 3. 3 divided by, and the one on the bottom is this one, is square root of 3. So then 4, you can say it's just 3 square root of 3 square times square root of 3. I just multiply both sides by square root of 3. So then for the 3 will cancel out and you have square root of 3. So here it's just 10. 10 of theta is equal to square root of 3. Okay? So let's draw the unit circle. I don't know what it is, but let's draw the unit circle. So let's try this one. If you look at this one, we have pi over 3. So if you take the 1/2 here, that's the cosine. Okay, cosine of theta is 1/2. Cosine of pi over 3 is, just let me see if it's the right one. And the sine here is sine of pi over 3 is square root of 3 divided by 2. Now, 10 of pi divided by 3 is just this one. It's just the sine divided by cos, which is square root of 3 divided by 2, and flip it is 2. Yes, you're right. You're right. I was right. Okay, this one is good. So then for you can conclude theta is just pi over 3. Okay, that's it. That's the question they ask. Please review that one, okay? Review it and be careful. That's all I tell you. Just be careful, okay? Review it well and understand the process, okay? If you have any question, please let me know, okay? Now let's do question number 18 now. Now question number 18, problem number 18. Okay, let's do problem number 18. Problem number 18, they ask you to describe and scratch the surface area. So you have 8. 8, you have x squared plus z squared is equal to 1. Okay. And you know there is something missing, and the one is missing is the y. And remember last time I told you the one is missing since it's a y, then you have a equation of the plane. And the plane is, the equation of the plane is, you can call it c. Y is equal to c. That's the equation of the plane, okay? So this one is a circle. It's a circle center at 0, 0. And make sure it's a 0 here, because you have here 0. And then you have the radius r is 1. Okay. Now we have to graphic now. And we have here y, and here you have z. And remember, on the xz plane, let me write down black. On xz plane, now on xz plane, here is x. On xz plane, what's the cross section? And the cross section is called here trace. On xz plane, the trace here is a circle. Why is a circle? Because of the equation. Because of this one, the equation. Is a circle center of 0 and the radius 1. So just make sure you have here 1 and you have here 1. So you have a circle here. And again, this one is the equation of the plane. It's just the plane from x to z. That's the plane for x to z. Okay? So now, it will be like this. It will keep going. It will be the same. It will keep going. So now, since the plane is y is equal to c, and y is missing, then the line will be parallel to the y-axis, and that line is called rulings. Just like I told you last time in class when I was doing the lecture. The rulings will be parallel on the y-axis. And those rulings will be like that. And you can see now you have a cylinder. That's how you construct a cylinder. Again, is in 3-dimensional, okay? It's not in 2-dimensional. It's not easy to see, but it's beautiful, okay? That's the way you have to look at math. That's it. That's the question I ask you. I will ask you those type of questions. Get ready, okay? Just understand the process and you should be good. Okay, the next one, let's do B. B, you have 4x squared plus y squared is equal to 4, okay? So if you have those type of equation, I know I didn't go over a lot of them, but I just want to tell you the most needed one in your life is about the ellipse. Ellipse, Okay, if you have ellipse in the plane, for example, if you have, and you can tell here, since Z is missing, you can tell Z is missing. But since Z is missing, so you will have a plane of Z is equal to C is a plane. So is a plane such that that plane, the rulings will be parallel to the Z-axis. That's how you can describe geometrically the ellipse cylinder. And you can build the ellipse cylinder, by the way. Okay? And here is just a circular cylinder. Okay? This one is just a cylinder. So this one you will build, the next one, the B, you will build an elliptic cylinder. Remember, elliptic cylinder. Everything will end up be a cylinder. Why elliptic? Because of the equation. Why this one is a circular cylinder? Because the equation is a circle. That's all. Okay? Don't be confused about the name. Okay, let's start here. So you have this one. So you have 4x squared plus y squared is equal to 4. If you divide both sides by 4, you have x squared plus y squared divided by 4 is equal to 4. And you have x squared plus y divided by 2, everything squared is equal to 2 squared. No, it's 4 divided by 4. Sorry about it. It's 4 divided by 4, which is 1. So you have x squared plus y divided by 2, everything squared is equal to 1. And remember the equation of the ellipse. Recall the equation of the ellipse is x divided by b square plus y square divided by, you can call it 8 square, and you can have here 1. It's always equal to 1. This one is the equation of the ellipse. Okay? Good. So you have this one. So this one is the equation of the ellipse. So now to graph this one, since Z is missing, so you have a plane Z is equal to C. So that means the cylinder will cross the rulings will be parallel on the y-axis in a geometric view. So you have three-dimensional, which is x and y and z. You have x here, so you have y here, and you have a z here. Okay, you have this one. And remember here you have 1. So on the x-axis, point out 1 first. Okay? On the y-axis, you have 2. Okay? And then you can tell easily now the trace mean the cross section. The trace will be a cylinder, but that cylinder is different. It's different on the side. It's not a circle base of the origin, because the sides are different. Look at this side. This side is 1 and this side is 2. Since they are different and you have a cylinder, then it's elliptic. Elliptic. Okay? Remember that one. So the shape will looks like this. Okay? That's the shape. That's the shape. That's how the shape will looks. And we will keep going up. And we'll keep going up because of here. Because of here you have equation of the plane of Z is equal to C. It's a constant plane. And we'll keep going up. And then you can use the rulings to build an electric cylinder. So the way you have to build the elliptic cylinder is like this. You go up, you go up, you go up. Okay, now you build an electric. Sorry about my shape. I don't know how to draw well. Let me erase here. So you go up just like this. Okay? And that's the way you build and then you can, and the line will be parallel to and the line will be parallel to the z-axis. And that's the way you build it. You keep going like this. Okay, it's like this. So the line joining them, the line joining the trace is called rulings. And those lines, it will be parallel to the z-axis. And now you have your cylinder. And it's called elliptic cylinder. No, cylinder. Elliptic cylinder. And this one is called circular cylinder. Just like I told you right now, circular because of the circle. Because of the equation is a circle. Again, I have to repeat it. Okay? The equation is a circle. That's why you have a circular cylinder. Very good. And you have this one. And that's it. That's the way it will look. Okay? Good. And now let's do the next one. So the next one you have okay, the next one you have let me see it here, B. The next one you have C, and the C is Z is equal to 1 minus Y squared. Now I have to go fast now, since now you understand. So just make sure to make a difference between the one missing first and understand the trace and understand also the rulings. So you have this one now. So here you can tell you have one missing, which is X. X is equal to C, and which is a plane, okay? Okay, you have this one. First, you have a function of Z in terms of Y. So how is look just without thinking about three-dimensional, in two-dimensional, in X, in YZ plane. Okay, let's graphic in YZ plane first. I advise you to do that. It will make your life easy. So in YZ plane, how you can graph that function is this. So if you look at this one, that function will looks like this. This one is just y squared. Listen up here. This one is just y squared. This one is just y, it's just z is equal to y squared. Let me write down here. Z is equal to y squared. Now, if you take negative y squared, it will flip down. So you have negative y squared, it will looks like this. That's a negative, that's a z is equal to negative y squared. Got it? Okay. Now, plus 1, plus that one, plus 1. So that's mean the graph will go up to 1 here. That's the 1. The graph will go up to 1. And you have that shape. And you have that shape now. And you have that shape. Got it? Okay. So the graph will go up to 1. You have here 1. It will go up to 1. It will look like this. That's the z is equal to 1 minus y squared. That's the graph. Just to tell you how the graph looks. That's how the graph looks. Okay, remember. So now, let's go back to in three-dimensional now. In three-dimensional, so you have here z, and you have here y, and you have here, for example, x. Okay, you have this one. And remember some things on this plane, here, that plane. On that plane, how the shape will look like this. I mean the cross section, I mean the trace. The trace will look like this. That's the trace. Remember, that's the trace. Now, since x is missing, then x is equal to c is a plane. And the trace will cross on that plane. Okay? But it won't touch it. Look at here. Again, it will look like this. That's how the shape will look. just like this. It will looks like this, and you have this one here. And you and now since the x is missing, then the rulings will be parallel on x-axis. That's how the shape will looks. The shape will looks like this. It's beautiful. Okay? And just make sure x has to be here. My drawing's bad, but x has to be here. It will looks like this. And you have another one here. And you have this, like this. It have to be parallel to x-axis. Always have to be parallel on x-axis. It will looks like this. Okay? Okay, good. So you have this one. Okay, you have this one. And now, since it will be parallel on the x-axis, it will look like this. The rulings. That's how the shape looks. And just make sure, let me cross here, because x has to be like this. Yep, exactly like this. Okay, now I get it. Here is x. That's it. That's how the shape looks. Okay? That's how the shape looks. And also you can keep going. It will be a huge one. It will be a huge one. It's just like a purple and you put it down a little bit. It's the same thing. So it will looks like this. It will keep going like this. Okay? You keep going like this. It will be huge. It will be huge. Yeah, in geometric view, it's how it looks. Okay? And now you can cross them. You can combine them so you will have a cylinder. Okay? Just to give you an idea how things work. Okay, now this one was C. Let's do the D. The D is easy. It's up to you. If you want me to do it, I can do it. So let's do the D. Very quick. D is y is equal to z. Y is equal to z. Y is equal to z. Z square. Okay, you have this one. Y is equal to z square. So if you look at here, you have x missing. X is equal to c is a plane. That's the plane. That means the rulings will be parallel on the x-axis. That's it. So now, just to graph on, let's graph YZ plane. YZ plane. Let's graph YZ plane on the equation. So you have this one, Y and Z here. You have Y and Z. So you have Y here and you have a Z here. Okay, you have this one. How it look? It will look like this. It will look exactly like this. Okay? It will look exactly like this. So you have this one now. And now the question, okay, now if you want put it in three-dimensional, so you have here x. And remember, x will go like this. This one is a negative side. And this one is a negative side for y. Negative side for x, negative side for z. Okay, it will look like this. Now, since the rulings will be parallel on x-axis, it will look like this. That's the trace. The trace will look like this. And now, since it will be parallel on the x-axis, oh, sorry, let me draw this one. Okay. Okay, now you have this one. So the rulings will be parallel on the x-axis. You can draw like this. That's the rulings. That's the rulings. It will look like this. That's how it look. And you keep going here, it will look like this. On the bottom, I know you know how to draw it, but I don't. It's just hard for me to draw it. You have this one, and this one will combine with this one. Okay? That's how it look. Okay? I know you, okay, let me make it nice so you can see geometrically how it look. Okay, let me show you how it look. Okay, let me just Move here a little bit so you can see. This one will be like this. Okay. And the rest will, on the top will be like this. That's how it look. Okay. And here, make sure here is Y. And that's it. Okay. It will combine like this. Good. And the next one, let's do question number, let's do the E. So the E is X, Y is equal to 1. Okay, you have this one. So this one, remember, you used to have, everybody know how to graph 1 over X. So if you look at here, you have Y is equal to 1 over X. That's it. So here, the way you graph it is easy. So you have here, let's graph this one in XY plane, okay? XY plane. In XY plane here, it will look like this. Okay? It will look like this. XY plane. It will look like this. That's XY plane. Okay? If you want, you can also do it like this. The bottom, whatever. You can graph whatever you want, like this. Okay? You can keep going on the other side also. Okay? That's how it look. Now, let's graph this one in 3-dimensional now. Here is Y, here is X. Now in 3-dimensional, so you have X, you have Z here, and you have X here, and you have Y here, and X here, and you have Y here. Good. Okay, you have this one. So how you can graph this one? Remember, this one is XY plane. So if you look at, since Z is missing, listen up here, Z is missing, then Z is equal to C is a plane. So that means the rulings will be parallel on the Z axis. So if you look at the XY plane, so you can draw it like this. That's XY plane in 3-dimensional, in 3D. 3-dimensional. So 3-dimensional, it will look like this. That's a 3-dimensional. It will look like this. Okay? It's just like this. Here. It's just this one. It's just this one. You see this one? It's here. It's X, Y, X, Y. Look at here. I want you to understand. Here is X, here is Y. Here is XY, here is XY. Got it? Good. It's how it looks. Now, since Z is missing, the plane will be parallel to the Y axis, not to the Z axis. So you can keep going up and down, okay? You can keep going up. If you want, it will be like this. Always like this. Always like that. Always like that, okay? Just like that. So since Z is missing, it's parallel on the Z axis, it will look like this. That's how it looks. Okay? The other side also you can draw it. The other side also you can draw it like this. Same thing. You can draw like this the other side. If you want. But you don't have to. This one is sufficient. Good. Okay, the next one, let's draw the sign. Okay, I think my screen is stuck. If you're stuck, okay, just let me draw then here. Just let me do it then here. Yeah, it seems like my screen is stuck. Okay, that's fine. Just let me do it here. Okay, let's do the last one, F. Again, don't do number 19, okay? 19, it won't be on the exam. Problem number 19, again, it won't be on the exam, okay? If anyone is absent, let them know. Problem number 19, it won't be on the exam. So just let's stop on 18. So you have Z is equal to sine of Y, and you see here X is missing. If X is missing, then the rulings will be parallel on the X axis. And you know, if you have Y and Z here, and the sine, it will cross at the origin. It will look. That's the sign. That's how the sign will looks. That's the equation of the sign. Okay, that's the sign. That's how the sign will look. This one is a sign of Y. Now Now, in 3D, to graphic in 3D, you have here X. So to graphic in 3D, it will look like this. You have this one, and you cross here, and you cross here, and you go. That's how it look in 3D. Now, since X is missing, then it will be parallel on the X-axis. That's how it look. That's how it look. Okay? That's it. This one is F. You don't have to do 19 no more. Thanks. And study hard. Next week is your exam. Good luck.